11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Coordinate Geometry. Topic Hyperbola. Subtopic Equation of a conic section having given eccentricity, focus and directrix. Standard equation and simple properties of hyperbola. Exercise 11.4. What is hyperbola? A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. Hyperbola haibasi plane amada leiba set of points ni adugumba point ado plane aduda leiba fixed point anidagi arapa anidugi difference to matam pumnamakta constant hadi real number ama oirabadi adugumba set of points tuna hyperbola ama seme. In this picture, this green one is, this two green part is hyperbola. For P is a point, F1 and F2 are the two fixed points. The two fixed points are called the foci of the hyperbola. That is, in this picture, F1 and F2 are the foci of the hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola. Foci anigi midpoint asibu center of the hyperbola kawi. The line through the foci is called the transverse axis, and the line through the center and perpendicular to the transverse axis is called the conjugate axis. Focus ani phawraga satliba line asibuna transverse axis kawi, aduga center amasung axis the center phawba axis the perpendicular oibalai asina conjugate axis kawi. The points at which the hyperbola intersects the transverse axis are called the vertices of the hyperbola. Transverse axis ka hyperbola ka kaknapam points sing asibu figure asida point ani asi vertices of the hyperbola kawi. Eccentricity. The eccentricity of a hyperbola is the ratio of the distances from the center of the hyperbola to one of the foci and to one of the vertices of the hyperbola. That is, eccentricity is denoted by E, which is equal to C by A. C is what? One of the foci from the center. A is what? A is the distance of one of the vertices from the center. Establish the standard equation of the hyperbola x square by a square minus y square by b square equal to 1, which is also in the textbook as in this picture. Another form of hyperbola is y square by a square minus x square by b square equal to 1, whose picture is upward nave and downward nave. Foci lie on the y-axis. This point B and this point A are the vertices, and the conjugate axis along this and transverse axis on the y-axis. Note 1. A hyperbola in which A equal to B is called an equilateral hyperbola. For hyperbola, we have C square equal to A square plus B square. Latus rectum. Latus rectum of hyperbola is a line segment perpendicular to the transverse axis through any of the foci and whose endpoints lie on the hyperbola. The length of the latus rectum of the hyperbola is twice b square by a in all forms of the standard equation. Exercise 11.4. Question number 1. Find the coordinates of the foci and the vertices, the eccentricity and the length of the latus rectum of the hyperbola x square by 16 minus y square by 9 equal to 1. The equation of hyperbola is this. Comparing this with the standard equation, we get a square is 16, b square is 9. Solving, we get a equal to 4, b equal to 3. Using c equal to square root of a square plus b square, we get c equal to square root of 16 plus 9, that is 5. Therefore, foci for above equation is plus minus c0. C is 5. We get this. Vertices is plus minus a0, whose values are plus minus 40. Eccentricity is obtained when c is divided by a, that is 5 by 4. Length of the lattice rectum is twice b square by a. B is here 9, b square is 9, a is 4, we get 9 by 2. Equation 2. Find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbolas y square by 9 minus x square by 27 equal to 1. The equation of hyperbola is this. Comparing this with the standard equation, we get a square is 9, b square is 27. Therefore, a is 3, b is 3 root 3. Using c equal to square root of a square plus b square, we get c equal to square root of 9 plus 27, that is 6. Therefore, foci is 0 plus minus c. Giving values of c, that is 6, we get this. Vertices 0 plus minus a, whose values are 0 plus minus 3. Eccentricity E is given by c by a. C is what? C is in this case, c is 6. A is what? A is in this case 3. 6 by 3 is 2. The length of the lattice rectum is twice b square by a, giving b square 27 and a equal to 3, we get 18. Find the coordinates of the foci, the vertices and the eccentricity and the length of the lattice rectum of the hyperbolas. Question number 3. Divide on both sides by 36, we get this, which is similar to question 2. For question number 4, divide on both sides by 576, we get this, which is also similar to question 1. For question number 5, divide on both sides by 36, we get this. Comparing with the standard equation, we get a square is 36 by 5, b square is 36 by 9, that is 4. Using c equal to this, c equal to root over a square plus b square, we get c equal to square root of 36 by 5 plus 4, that is 2 times root over 14 by root over 5. Foci, as y foci becomes this. In this case, the foci must be 0. The hyperbola should be transverse axis on the y-axis. Therefore, 0 plus minus c. Put the value of c, that is 2 root over 14 by root over 5. Vertices is, in this case, vertices is this point with this point. There is 0 plus minus a. Put a equal to 6 by root over 5, we get this. Eccentricity is e equal to c by a equal to e is root over 14, a is 3, we get this. Length of lattice rectum is twice b square by a, that is 2 into 4 divided by 6 by root over 5. Simplify, we get 4 times root over 5 by 3. Question number 6. Divide on both sides by 7i4, we get this, which is also similar to question 2 above. 7. Find the equation of the hyperbola satisfying the given conditions. Vertices plus minus 20, foci plus minus 30. Vertices this, then vertex lies on the x-axis. Therefore, transverse axis of this hyperbola will be this, such type of diagram. Vertex is this. Foci is this. Let the equation of the hyperbola be x square by a square minus y square by b square equal to 1. The transverse axis is x-axis as the focus or vertex lie on the x-axis. Then comparing with these vertices and foci, we get a equal to 2 and c equal to 3. Using c square equal to a square plus b square, we get b square equal to 9 minus 4, that is 5. Therefore, the equation of the hyperbola is x square by a square whose value is 4, and minus y square by b square whose value is 5, exactly 5. Find the equation of the hyperbola satisfying the given conditions. We are given 2 conditions from which we have to find out the equation of the hyperbola. Let the equation of the hyperbola be y square by a square minus x square by b square equal to 1, as the vertices lie on the y-axis or foci lie on the y-axis. Therefore, the standard equation of the hyperbola is y square by a square minus x square by b square equal to 1. Let us see this picture. This is vertex, this is foci. Then comparing this with the given values, we get a equal to 5 and c equal to I. Using c square equal to a square plus b square, we get b square equal to 64 minus 25, that is 39. Thus, the equation of the hyperbola is y square by 25 minus x square by 39 equal to 1. Question number 9, similar to question number 8. 10. Find the equation of the hyperbola satisfying the given conditions. Foci plus minus 50, the transverse axis is of length I. The hyperbola be x square by a square minus y square by b square equal to 1. As foci lies on the x-axis, therefore the transverse axis is on the x-axis. This is foci. Comparing this equation with the given values, we get c equal to 5 and twice a. Transverse length of transverse axis is twice a, which is given as I. Solving, we get a equal to 4. Using c square equal to a square plus b square, we get b square is 5 square minus 4 square, that is 3 square. Therefore, the equation of the hyperbola is x square by 16 minus y square by 9 equal to 1. Question number 11. Find the equation of the hyperbola satisfying the given conditions. Foci 0 plus minus 13, the conjugate axis is of length 24. We get this. Let the hyperbola be y square by a square minus x square by b square equal to 1, as the foci lie on the y-axis. Similar to such type of hyperbola will be. Then comparing this equation with the given values, we get c equal to 13 and length of conjugate axis twice b, which is given as 24. Solving, we get c equal to 13 and b equal to 12. Using c square equal to a square plus b square, we get a square is 13 square minus 12 square, that is 25. After knowing the values of a and b, therefore the equation of the hyperbola is y square by a square is 25 minus x square by b square, that is b square is 144 equal to 1. Question number 12. Find the equation of the hyperbola satisfying the given conditions. Foci plus minus 3 root over 50, the lattice rectum is of length I. Let the hyperbola be x square by a square minus y square by b square equal to 1, as the foci lie on the x-axis. Comparing this equation with the given values, we get c equal to 3 root over 5 and the length of lattice rectum from this equation is twice b square by a, but its value is given as I. Comparing this, we get c equal to this and b square equal to 4a. Also, c square equal to a square plus b square, we get 3 root over 5 whole square equal to a square plus b square is substituted by 4a. We get a quadratic equation in a. Factorize and solve a two values of a, from which we have to take a equal to 5 as a equal to minus 9 is invalid, because length of 2 points cannot be negative number. Using, therefore, b square is 4 into 5, that is 20. We have known a and b. Therefore, the equation of the hyperbola is x square by a square, a whose value is 5, whose square is 25, minus y square by b square, whose value is 20 equal to 1. Find the equation of the hyperbola satisfying the given conditions. Foci plus minus 40, the lattice rectum is of length 12. Let the equation of the hyperbola be x square by a square minus y square by b square equal to 1, as the foci lie on the x-axis. Comparing this equation with the given values, we get c equal to 4 and the length of lattice rectum from this equation is twice b square by a, but its value is given as 12. We get this c equal to 4 and b square equal to 6a, but c square equal to a square plus b square, from which we get a quadratic equation in a. Factorize and solve two values of a, from which we have to take a equal to 2, as a cannot be negative. Other value minus 8 is invalid. Using b square equal to 6a, we get 12. Thus, the equation of the hyperbola is x square by 4 minus y square by 12 equal to 1. Question number 14. Find the equations of the hyperbola satisfying the given conditions. Vertices plus minus 40, eccentricity E is 4 by 3. Let the equation of the hyperbola be x squared by a squared minus y squared by b squared equal to 1 as the vertex lie on the x-axis. Then we get a equal to 7, but e equal to 4 by 3, but e is again equal to c by a. We get c equal to 28 by 3. Also, c square equal to a square plus b square, from which we get b square is equal to 343 by 9. Therefore, the equation of the hyperbola is x square by 49 minus 9y square by 343 equal to 1. Question number 15. Find the equation of the hyperbola satisfying the given conditions for size 0 plus minus root over 10 passing through 2, 3. Let the equation of the hyperbola be y square by a square minus x square by b square equal to 1 as the foci lie on the y-axis. Then we get c equal to root over 10. The hyperbola passes the point 2, 3. Therefore, the coordinates of this point will satisfy the above equation. We get equation 1. Also, c square equal to a square plus b square. Putting respective value c square, we get a square equal to root over 10 square minus b square. A square equal to 10 minus b square. Equation 1 implies a is the substituted. In equation 1 a is substituted its value 10 minus b square. We get this factorized. We get this equation. Putting b square equal to z, we get a quadratic equation in z. Factorize, solve z to values. Z is replaced by its equivalent value b square. We get b square equal to 5. Therefore, the equation of the hyperbola is y square by 5 minus x square by 5 equal to 1. Thank you for watching video.